This is a video from section 5.5 in a Calculus 1 class. The problems will be taken from the Stored Calculus textbook, 9th edition. The directions say to evaluate the indefinite integral. And we're going to start off with problem number 10. Suppose I had the integral of 5 minus 3x to the 10th power dx. This is a classic u substitution problem. And we're going to let u equal 5 minus 3x. du is equal to negative 3 dx. Now you want to solve for dx. And to do that, we divide both sides by negative 3. So dx is negative 1/3 du. And so this integral can be rewritten as follows. It's negative 1/3 times the integral of u to the 10th du. So if you notice, we transformed it into something that's much easier to integrate. That's the whole idea of u substitution. So this is negative 1/3 times 1 over 11 u to the 11th plus c. But u is 5 minus 3x. So this is negative 1 over 33 times 5 minus 3x raised to the 11th power plus c. Remember, c is constant. And that's how you do problem number 10. Let's take a look at problem 14. Suppose we have the integral of secant squared of 2 theta d theta. So the inside function ends up being 2 theta. So I'm going to let u equal 2 theta. So du is 2 d theta. Solving for d theta, we get d theta is 1/2 du. So we divide both sides by 2. And so this is 1/2 the integral of secant squared of u du. And so this is 1/2 tangent u plus c. But remember that u is equal to 2 theta. So this is 1/2 tangent of 2 theta plus c. That's problem number 14. Let's take a look at problem 18. Suppose we have the integral of z squared divided by z cubed plus 1 dz. So I'm going to let u equal z cubed plus 1. du is 3z squared dz. Now for a problem like this is you want to collect the z's and the dz's on one side, everything else on the other side. And so I'm going to divide both sides by 3 to get z squared dz is equal to 1/3 du. And so this is 1/3. I'm going to pull that out in front of the integral. And then I can replace z cubed plus 1 with u. And then z squared dz is equal to 1/3, which is on the outside of the integral, du. So I'm going to put a 1 up on top there, right? And notice the second line looks much easier to integrate than the first line. So this is 1/3 natural log of the absolute value of u plus c. But remember, u is equal to z cubed plus 1. So this is 1/3 natural log of the absolute value of z cubed plus 1 plus c. And that's how we do problem number 18. So let's take a look at problem number 22. Suppose we have the integral of sine of 1 over x divided by x squared dx. Now, if you don't mind, I'm going to write this as the integral of sine of 1 over x times 1 over x squared dx. So, in other words, I'm taking sine of 1 over x, and I'm taking that quantity times 1 over x squared dx. That is legal. And so the inside function is 1 over x, so I'm going to let u equal 1 over x. Du is negative 1 over x squared dx. So if I solve for 1 over x squared dx, I get negative du. And so this is negative the integral of sine of u du. But this is negative of negative cosine u, right, plus c. So the antiderivative of the sine is negative cosine, but don't forget we have a negative on the outside. So this all works. But remember that u is 1 over x. And so when I substitute that back in, I get cosine of 1 over x plus c. And that's how we do 22. 26. Suppose I had the integral of sine of x multiplied by sine of cosine of x dx. The inside function here is cosine of x. So I'm going to let u equal cosine of x. I go for the inside function. That's where I start. So du is negative sine x dx. So sine x dx is negative du. Okay. So I'm going to pull the negative out in front. Now, sine of x dx along with the negative sign, right? Well, let's back up. Sine of x dx becomes negative du. So I'm going to put the negative on the outside of the integral sign. And then I end up evaluating sine of u, right? Because I'm going to replace cosine x with u du. So this is the opposite of negative cosine u, right? Plus c. So this is cosine of cosine x plus c. Because remember, u is cosine x, so I just stuffed that back in for u. And that's how you do problem number 26. Let's go ahead and take a look at problem 30. Suppose I have the integral of 1 over ax plus b dx. And one thing to note on this problem, in the context of this problem, is a does not equal 0. So I'm going to let u equal ax plus b. Du is equal to a dx. So if I solve for dx, I get 1 over a du. I divide both sides of the equation by a. So this is 1 over a times the integral of 1 over u du, which is 1 over a times natural log of the absolute value of u plus c. But remember, u is equal to ax plus b. So the correct answer here for problem 30 is 1 over a natural log. Now I'm going to replace u with ax plus b, so I get natural log of the absolute value of ax plus b plus c. And That right there is problem 30. Let's take a look at 34. Suppose I had the integral of secant squared x divided by tangent squared x dx. There's lots of ways to go in this problem, but I think the path of least resistance here is to let u equal tangent x du is secant squared x dx. And so this integral becomes, now I'm going to replace u with tangent x. So I get u squared on the bottom. And then I get 1 on top, and then I'm evaluating that integrand with respect to u. But this is negative 1 over u plus c. But remember that u is tangent x. So this is negative 1 over tangent x plus c, which is negative cotangent x plus c. And that's how we do 34. Let's take a look at problem number 38. On problem number 38, we have the integral of sine theta cosine theta divided by 1 plus sine squared theta d theta. This one's really good. So I'm going to let u be equal to 1 plus sine squared theta, which, by the way, is always positive, okay? That's going to come up in a minute. Du is 2 sine theta times cosine theta d theta. Do not call that sine 2 theta, okay? We need to leave that alone. So I'm going to solve for sine theta cosine theta d theta. So thetas and d thetas on one side, everything else on the other side. So dividing both sides by 2, I get sine theta cosine theta d theta is 1/2 du. And so this is 1/2 the integral of 1 over u du, which is 1/2 the natural log of u plus c. And if you notice, I did not put u in absolute value, and the reason why is because u is always positive no matter what I input for theta. And so the correct answer for problem number 38 is 1/2 natural log of 1 plus sine squared theta plus c. And that was 38. Let's take a look at 42. So on 42, we have the integral of 2 to the t divided by 2 to the t plus 3 dt. I'm going to let u equal 2 to the t plus 3, which again is always positive. Du is 2 to the t natural log of 2 dt. So 2 to the t dt is 1 divided by the natural log of 2, okay, du. And so this is 1 over the natural log of 2 times the integral of 1 over u du. So this is 1 over natural log of 2, natural log of u, and again, u doesn't have to be put in parentheses. Same argument, plus c. Now I get to replace u with 2 to the t plus 3. So I get 1 over natural log of 2 times natural log of 2 to the t plus 3 plus c. And that was number 42. Let's take a look at 46. Suppose I have the integral of sine x divided by 1 plus cosine squared x dx. I'm going to let u equal cosine x because I know that the derivative of cosine x is negative sine x, which is present, in the integral. So du is negative sine x dx. If I solve for sine x dx, I get negative du. So I'm going to pull the negative out in front, and then I'm going to integrate 1 over 1 plus u squared du. So this is negative arctangent of u plus c. But u is equal to cosine x. So this is negative arctangent of cosine x plus c. And that was number 46. Let's take a look at number 50. Suppose I have the integral of x over 1 plus x to the 4th dx. Okay? Well, this can be written as the integral of x over 1 plus x squared squared dx. So I'm going to let u equal x squared. Du is 2x dx. So solving for x dx, I get 1/2 du. So in other words, I just divide both sides by 2. And so this is 1/2 the integral of 1 over 1 plus u squared du, which is 1/2 arctangent, okay, of u plus c. But remember that u equals x squared. So the correct answer here to problem 50 is 1/2 arctangent of x squared plus c. That's 50. Interestingly here, let's take a look at 54. Suppose I had the following integral. So if I have x cubed times the square root of x squared plus 1 dx. Okay. There's a couple of ways that we can go about this. But the first thing I'm going to do is I'm going to take x cubed and break that up into x times x squared times the square root of x squared plus 1 dx. Okay, so what I'm going to do is I'm going to let u equal the square root of x squared plus 1. Square both sides. So u squared is x squared plus 1. 2u du is 2x dx. I can cancel the 2's and basically say u du is equal to x dx. Does that look okay? Now, if u squared equals x squared plus 1, then x squared is equal to u squared minus 1. Now I got substitution for everything. So if I have the integral of x times x squared times the square root of x squared plus 1 dx, now remember something. Remember that the square root of x squared plus 1 was my u, right? Now, if I go back, right, x squared is equal to u squared minus 1. So I'm going to replace x squared with u squared minus 1. X dx becomes u du. Okay, now this is the integral of u squared times u squared minus 1 du, which is the integral of u to the fourth minus u squared du. So I just distribute in. So this is 1/5 u to the fifth minus 1/3 u to the third plus c. But remember that u is equal to what? The square root of x squared plus 1. So if you don't mind, I'm going to substitute that in. So this is 1/5 times the square root of x squared plus 1 to the fifth minus 1/3 times the square root of x squared plus 1 raised to the third plus c. Now, another way you can write that is 1/5 times x squared plus 1 raised to the 5/2 minus 1/3 times x squared plus 1 raised to the 3/2 plus c. And that'll conclude this video for section 5.5. And we worked on problems 10, 14, 18, 22, 26, 30, 34, 38, 42, 46, 50, and 54. Okay, thank you.